can build the largest, most heavily funded security operations center on the planet, but without properly configured raw telemetry at the endpoint, your analysts are essentially just staring into the dark. There is a common misconception, especially among junior analysts, that simply taking default Windows logs and routing them into a SIEM automatically creates security visibility. This diagram shows why that approach fails. If the endpoint itself isn't generating the specific data payload, the SIEM aggregator isn't storing intelligence. It is just archiving empty noise. Detecting advanced threats requires a structural rebuild of your endpoint logging from the ground up, rather than relying on whatever Microsoft enabled out of the box. To get true visibility, we have to move through 3 distinct stages: auditing basic authentication, unblinding native process tracking, and deploying granular XML-driven telemetry. Forensic visibility is an active architectural choice made at the endpoint level, not a passive byproduct of purchasing an aggregation tool. The foundational layer of Windows logging is tracking who actually enters the system. We do this by monitoring 2 primary event IDs, 4624 for a successful logon and 4625 for a failed logon. A single event ID 4625 usually just means a standard user made a typo, but a sustained programmatic attack leaves a specific footprint. This timeline illustrates a brute force attack. We look for a clustered pattern, many 4625 failure nodes in a tight sequence, terminating directly in a single 4624 success node. This cluster proves the threat actor breached the perimeter, revealing the compromised user account name. Authentication logs prove exactly who breached the perimeter and when, but they are critically limited because they cannot reveal what the attacker executed next. To see post-breach execution, we need the next layer of visibility, Event ID 4688, process creation. There is an architectural flaw in Event ID 4688's default state. It logs that a program executed, but it deliberately strips away the command line arguments. This split screen shows how native defaults blind analysts. Event Viewer on the left shows only PowerShell.exe. The raw XML on the right is missing command line arguments. If an attacker uses PowerShell maliciously, the arguments should exist right here, but they are physically absent. To unblind this telemetry, we have to engineer a fix by modifying the advanced audit policy configuration by group policy objects. We navigate through this group policy editor path: computer configuration, security settings, down to advanced audit policy, and into detailed tracking to audit process creation. Once there, we go into administrative templates and explicitly enable the setting to include command line in process creation events. Without manually forcing this policy change across the domain, analysts are left investigating sophisticated attacks while effectively blindfolded to the adversary's actual keystrokes. Even with command line auditing explicitly enabled, native Windows logging generates an overwhelming, unsustainable volume of benign operating system noise. We solve this by introducing System Monitor, or SysMon, a high-definition overlay deployed to actively filter this noise and isolate advanced persistent threats. This shows a SysMon XML configuration. SysMon uses Boolean rules to actively drop or capture data at the source. The exclude function preserves storage by dropping predictable background processes. Conversely, the include function explicitly traps suspicious behaviors, like a Word document spawning a command prompt. SysMon expands visibility beyond native constraints. SysMon ID 3 tracks outbound command and control network traffic, and it does so without needing deep packet inspection. SysMon ID 13 captures persistence mechanisms by logging the exact moment an attacker modifies the system registry. SysMon transitions an environment from reactive, noisy data hoarding into a proactive, high-fidelity detection grid tailored precisely to the organization's threat model. With these tools in place, we construct an investigative hypothesis, the methodology of correlating isolated event IDs into a complete chronological narrative of adversary movement. Consider a scenario where an analyst detects a late-stage anomaly on a domain controller. This timeline starts out blank. We must reconstruct the breach from right to left using our configured telemetry. The first piece of forensic evidence establishes initial access. We identify a dense cluster of event ID 4625s, ending in a 4624, originating from an external IP address. The second phase confirms the attacker's payload. By parsing event ID 4688 with command line auditing active, we reveal the execution of an obfuscated script. The final forensic link proves lateral movement and persistence. We correlate that script execution directly to a Sysmon ID3 network connection and a Sysmon ID13 registry modification, connecting the sequence into a solid, unbroken chain. Without the specific GPO adjustments and the Sysmon overlay, the entire middle of this operational timeline would be blank, rendering the investigation impossible. Mastering threat hunting is not about operating a specific dashboard. It is about understanding the operating system architecture intimately enough to force the endpoint to record the adversary's exact footprints.